Hello and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. And if you're listening to this on the morning of Wednesday, the 1st of April, here in Australia, there's a rocket on a launch pad in Florida right now, fully fueled, fully crewed, and pointed at the moon.
This is not an April Fool's joke.
Absolutely not. For the first time in over 50 years, human beings are preparing to leave Earth and head toward the moon. And today, on this very special episode 77 of Season 5, we are your countdown companion.
We have 6 stories for you today, and yes, Artemis 2 is front and center, but we've also got a record-breaking space laser, a 12-billion-year-old comet, a star born from the ashes of the very first stars in the universe, and a new chapter in the mystery of Saturn's rings.
It is without question one of the most extraordinary days in the history of human spaceflight. Let's go.
We begin where the world's attention is today, Kennedy Space Center, Cape Canaveral, Florida, where the countdown clock for NASA's Artemis 2 mission is ticking.
At 4:44 p.m. Eastern Time yesterday, that's early this morning for our Australian listeners, NASA flight controllers started the official countdown. Liftoff is targeted at 6:24 p.m. Eastern, which is 8:24 tomorrow morning AEDT.
The crew has been in quarantine at the Neil Armstrong Operations and Checkout Building following a strict schedule of sleep, nutrition, and technical briefings. Commander Reed Wiseman told reporters on the weekend, and I love this quote, "Hey, let's go to the moon."
That is the energy we need. Wiseman leads a crew of 4. Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian astronaut Jeremy Hansen. Together, they will become the first humans to travel to the vicinity of the moon since Apollo 17 in December 1972.
More than 53 years, and this mission, Artemis 2, won't land on the moon. It's a 10-day test flight. The Orion capsule, launched aboard the massive Space Launch System rocket, will perform a figure-8 trajectory, out around the moon, coming within about 6,000 miles of the lunar surface on April 6th, then back to Earth for splashdown in the Pacific on approximately April 11th.
The purpose is to stress test the Orion capsule's life support systems, with humans on board for the first time. Everything they learn paves the way for Artemis 3, now planned as a low Earth orbit docking test in 2027, and ultimately the first lunar landing since Apollo in 2028.
NASA launch director Charlie Blackwell Thompson reported yesterday that the countdown run-up has been, quote, extremely smooth, with only very minor ground equipment issues. Weather is currently forecast at 80% favorable. Some cloud cover and potential high winds on the ground are the primary concerns.
And NASA has confirmed there's a 6-day launch window from April 1st through April 6th before the next opportunity opens at the end of the month. So there's some flexibility if they need it.
For our Southern Hemisphere listeners, and this is genuinely moving, this is the moment our generation has been waiting for. The next chapter of human exploration of the cosmos begins Thursday morning, April 2nd at 9:24 a.m. Australian Eastern Time. And if in the U.S., 6:24 p.m. Eastern Daylight Time on April 1st, which all translates to 22:24 UTC on April 2nd. I hope I got all those conversions right.
We will be watching every second. Now, there was a dramatic subplot to yesterday's launch preparations. The sun decided to get involved. On Sunday night, a massive X-1.4 class solar flare erupted from an active sunspot region designated AR4405. It peaked at just after 11 p.m. Eastern Time and triggered a significant high-frequency radio blackout across the sunlit side of Earth, including, as it happens, parts of Southeast Asia and Northern Australia.
X-class flares are the most powerful category the sun produces. An X-1.4 is serious business. The flare also launched a coronal mass ejection, a massive cloud of solar plasma with a possible Earth-directed component.
So NASA had something of an anxious Monday morning. But at the L-2 press conference, Associate Administrator Amit Kshatriya gave everyone the all clear. Quote,
we're not expecting the CME to cause any effects. We're not tracking concerns for the mission in general. Artemis 2 is go for April 1st.
NOAA's Space Weather Prediction Center has issued a G2, that's moderate, geomagnetic storm watch for today, Tuesday, March 31st, with G1, minor storm conditions possible through launch day tomorrow.
And here's the silver lining for our listeners. That geomagnetic activity means auroras could be visible at lower latitudes than usual tonight. Under G2 conditions, the southern aurora, the aurora australis, may be visible further north than normal. Southern Hemisphere aurora watchers, get outside tonight.
We'll be watching the skies and the launch pad at the same time.
All right, now let's travel to the other end of the universe. Because while everyone's been watching the launch pad, astronomers have spotted something extraordinary in the deep cosmos.
Scientists have discovered the most distant and most powerful natural space laser ever detected. And I know that sounds like science fiction, but these things are very much real.
They're called masers, the microwave equivalent of a laser. Where a laser amplifies visible light, a maser amplifies microwave radiation. When a maser is powerful enough to be seen in other galaxies, it gets the name megamaser. And now, astronomers have found something so powerful, they're proposing an entirely new category.
A gigamaser. The signal comes from a galaxy system designated, deep breath, HATLS J 142,935.3 minus 2,836, located approximately 8 billion light-years from Earth. The light we're detecting began its journey when the universe was barely half its current age.
It was discovered by the Meerkat Radio Telescope Array in South Africa. 64 linked radio dishes working as one instrument. The detection was completely serendipitous. Team leader Tato Manamela from the University of Pretoria described it as, quote, "We are seeing the radio equivalent of a laser halfway across the universe."
And the mechanism is spectacular. Two galaxies are colliding. The gravitational violence of the merger compresses enormous clouds of gas, triggering a burst of new star formation. The intense radiation from those newborn stars then excites hydroxyl molecules, that's one oxygen atom bonded to one hydrogen atom, causing them to emit microwaves in a focused, amplified beam.
The signal is so intense, roughly 100,000 times the luminosity of a star, concentrated into a very narrow slice of the electromagnetic spectrum, that it warrants its own classification beyond megamaser. And it wouldn't even be visible without a stroke of cosmic luck. A completely unrelated foreground galaxy is perfectly aligned between the source and Earth, acting as a gravitational lens and amplifying the signal further.
Lead researcher Manamela said, "This is just the beginning. We don't want to find just one system. We want to find hundreds to thousands." The expectation is that when the square kilometer array comes fully online in South Africa, we'll start finding these gigamasers across cosmic history.
The universe is remarkable.
From one ancient signal to another, our old friend, the interstellar comet 3I Atlas, has just revealed a staggering secret about its age.
We've been following 3I Atlas since it was discovered, back in July 2025, the third known interstellar object to pass through our solar system. It swung around the sun, caused enormous excitement, and now it's heading back out toward Jupiter and beyond.
But new analysis using data from the James Webb Space Telescope has given scientists a remarkable new insight. By examining the isotopic composition of gases outgassing from the comet, specifically the ratio of carbon-12 to carbon-13 and the deuterium content of its water, researchers now believe 3I Atlas may be between 10 and 12 billion years old.
Let that sink in. Our sun is 4.6 billion years old. Earth is 4.5 billion years old. This comet may have formed nearly 3 times earlier than that, in the very earliest epoch of the Milky Way's history, when the galaxy was first igniting with star formation.
The chemical signature tells the story. 3I-ATLS's water contains more deuterium, a heavier form of hydrogen, than any comet previously studied. Its carbon isotope ratios are also markedly different from anything in our solar system. These signatures point to formation in an extremely cold environment, around 30 Kelvin. That's minus 243 degrees Celsius, in the early metal-poor protoplanetary disk of some ancient, long-vanished star.
And here's the haunting part. The star that gave birth to this comet, the star it originally orbited, almost certainly no longer exists. It would have burned through its nuclear fuel and died billions of years ago. 3I/ATLS has been drifting through interstellar space, alone, for longer than our planet has existed.
Researcher Romain Maggiola of the Royal Belgian Institute for Space Aeronomy put it beautifully. He said, if 3I-ATLS is indeed as old as this study suggests, the large amounts of volatile molecules it contains indicate that rich prebiotic chemistry may have already been occurring in star-forming regions very early in the history of our galaxy.
A comet as a time capsule from the dawn of the Milky Way. We may never get another chance to study one like this.
And staying with the theme of ancient messengers, astronomers have found a star in our own cosmic backyard that preserves the chemical fingerprint of the very first stars that ever existed.
The star is called Pictor II-503, and it lives in an ultra-faint dwarf galaxy called Pictor II about 150,000 light-years from Earth, which in cosmic terms is practically next door. The galaxy itself is more than 10 billion years old.
Pictor II-503 is what astronomers call a second-generation star, meaning it formed from the debris of the very first stars in the universe. Those first stars, made almost entirely of hydrogen and helium, burned hot and fast and exploded in supernovae, scattering the first heavier elements into the cosmos. Pictor II-503 formed from that debris.
The evidence is unmistakable. The star contains less iron than any other star ever measured outside the Milky Way, less than a 40,000th the iron content of our Sun, and it's enormously rich in carbon. That specific chemical signature is the hallmark of material enriched by the first generation of stellar explosions.
The discovery, published in Nature Astronomy in March, was led by Ani Ruth Chidi, a Brinson Prize Fellow at Stanford University. It used the dark energy camera at the Victor M. Blanco 4-meter telescope at Cerro Tolo Inter-American Observatory in Chile. So this is beautifully a Southern Hemisphere discovery.
MIT astrophysicist Anna Frabel, who was not involved in the study, told Science News, "It's a fantastic discovery. I know how hard it is to find these stars. They are so rare."
What's making this particularly significant is that Pictor II-503 is the first unambiguous example of a second-generation star found inside an ultra-faint dwarf galaxy, like Pictor II, which matters because it validates the theory that many of the most primitive stars we see in the Milky Way's halo were originally formed in tiny, ancient dwarf galaxies like Pictor II, which eventually merged with our own galaxy over cosmic time.
As NSF Program Director Chris Davis put it, discoveries like this are cosmic archaeology, uncovering rare stellar fossils that preserve the fingerprints of the universe's first stars. I love that phrase, cosmic archaeology.
And we close today with Saturn, because who doesn't love Saturn, and a fresh new chapter in one of planetary science's best mysteries. Where did those magnificent rings come from?
Saturn's rings are one of the most iconic sights in the solar system. But here's the thing, they're surprisingly young. Saturn itself is over 4.5 billion years old, but its rings appear to be only somewhere between 100 million and a few 100 million years old. The question has always been, why are they so young?
New research presented at the Lunar and Planetary Science Conference in Texas this month adds compelling new weight to what's become the leading hypothesis, that the rings were created when Saturn destroyed one of its own moons.
The hypothetical moon has been named Chrysalis, a beautiful name because it transformed into something else entirely. The scenario, led by Yifei Zhao of the University of California, Santa Cruz, goes like this. Sometime between 100 and 200 million years ago, the orbit of Chrysalis became gravitationally destabilized, sending it on a fatal trajectory towards Saturn.
Saturn's tidal forces then went to work. The simulations show that the planet would have preferentially stripped away the moon's icy outer mantle while leaving much of its denser rocky core intact. That distinction is crucial because it explains a long-standing puzzle. Why are Saturn's rings composed almost entirely of water ice with almost no rock?
Because the rock sank into Saturn and the ice became the rings. The stripped icy material remained in orbit, was gradually shaped and sculpted by the gravitational influence of Saturn's larger moons, particularly Titan, and spread into the magnificent ring system we see today.
And there's a bonus explanation. Saturn has a surprisingly steep axial tilt. It's tilted about 26.7 degrees. The loss of chrysalis is thought to have been the gravitational trigger that knocked Saturn out of a resonance with Neptune, which had been controlling its tilt for billions of years. Lose the moon, lose the resonance, and the tilt changes.
As lead researcher Zhao told Space.com, this scenario can clearly explain why Saturn's rings are young. It's one of those moments where a single event, a moon falling to its doom, explains multiple mysteries at once.
Chrysalis, the moon that became a butterfly, or in this case, one of the most breathtaking sights in the solar system.
And that is your Astronomy Daily for today, episode 77 of season 5. What a day to be a space fan.
Tomorrow, if all goes to plan, 4 human beings will ride fire into the sky and begin the journey to the moon for the first time since 1972. It's hard to fully comprehend what that means.
We'll be back as soon as we can with launch coverage. In the meantime, if you're in Australia or New Zealand tonight, look south. There may be auroras.
And if you're watching the launch and you feel a lump in your throat when that rocket clears the tower, that's exactly the right reaction.
From Anna and me, this is Astronomy Daily. Clear skies, everyone.
Astronomy.